Okay, geometry, this is day 2, or part B of our final semester review, picking up with problem 18, and then I think we're going to try to get through number 35. So this front and back page is what we'll try to get through in this video, and then we'll just have one more day. So number 18, we're working on quadrilaterals in chapter 6. So these are all down here. These are all like parallelograms, squares, rectangles, rhombus, kite, those type of things, okay? So they're going to give us some qualities up here for number 18, and it says that this guy is a rectangle. So we know that each one of these is right angles. We also know that like the length from D to B is the same as the length from A to C, you know, those type of things. So let's see what it gives us. It says angle DAC. DAC, which is this guy right here, that is a measure of 2x plus 4. That's what he is, okay? And then BAC, BAC is this top side right here. And that guy is a measure of 3x plus 1. That's what this top guy is, okay? And they want us to find the measure of BAC. So we have to first find out what x is, okay? So they give me this bottom side here and this top side here. And what I know is that this angle, since it's a rectangle, these two pieces have to add up to be 90 degrees. So I can just set that, that 2x plus 4 plus 3x plus 1 equals 90. And then I can just solve for x, okay? So 2x plus 3x is 5x. 4 and 1 makes another 5 equals 90. And then subtract the 5 to the other side. 5x equals 85. And if I divide by 5 on both sides, x is going to be 17, I believe. 8 divided by 5 is 1, with 3 left over. 35 divided by 5 is 17. Yep. So x is 17, but then they want to know what BAC is, okay? So BAC was the one labeled 3x plus 1. So if x was 17, 3 times 17 plus 1, I'm going to check that. 52 maybe. 3 times 17 plus 1. Plus 1. Oh, plus 1. Yep, 52. 52 degrees is what BAC is, okay? So notice that it's not necessarily the case that these two angles are going to be the same measure. Because they're not both 45s, even though they will add up to be 90, they're not both going to be the same measure. One of them is 52, this top one is 52, and the other one is like, I don't know, 38 or whatever the rest of that is, okay? Number 19 is a rhombus, okay? So in a rhombus, all 4 sides are exactly the same length, okay? And they tell us if the measure of angle KAL, this angle right here, is 2x minus 8. What is the measure of x? Okay, well, they don't give us any other information, but if this is a rhombus, we do know something about these diagonals. These two guys, where they come together, they will make a 90-degree angle. So each one of these will be a 90-degree angle going all the way around here, and that's one of the qualities of a rhombus. So I can just say that 2x minus 8 is equal to 90, okay? And then add the 8 to the other side. So 2x equals 98 divided by 2. 98 divided by 2 is 49, I believe. Yes, 49. Okay, so they just had to find x. We didn't actually have to solve for anything because really if we would plug back into KAL, we would know that it was 90, so which we already know. But 49 is what x is, okay? This guy is a kite. He looks like a kite, or has all the qualities of a kite. These two sides are the same. These two sides are the same. So that tells me that he is a kite. 70 degrees, 36 degrees. They want us to figure out what angle D is. Okay. Now, in a kite, it is true that it has 2 angles that are going to be the same, and it's the 2 that are like across from each other as the kite is like flying in the sky. So if you would think of the kite as being turned this way, these 2 angles are going to be the ones that are the same. Okay, now all 4 of these angles have to add up to be 360. So 36 and 70 is what's already there. 36 plus 70 is 106 if I add those 2 together. Okay, and if I subtract that from 360, that will give me what those 2 added together have to be. So let's try that. 360 minus 106, and I'm going to try to do that in my head, 254. Okay, So these two added together have to be 254, so then one of them individually is half of 254, since they're both the same, so I'm going to take that and divide by 2. And each one of them is going to be 127 degrees. So that tells me what D is. It also tells me what B is. They're both 127. Okay. All right, 21, last question. This one also kind of looks like a kite because these two sides are the same, these two sides are the same. They tell me that this guy is 12, this guy is 12, this guy is 20. They want to know what RH is, this length here. We don't know anything about that other than the fact that the two poles, that you shove through the kite, those have to cross at a 90-degree angle, which makes this a right triangle right here. So I have one side is 12, the other side is 20, and then this third side I can find by doing the Pythagorean theorem. So let's do that. This third side is going to be my side C because that's the longest side, so C is what I'm solving for. And then it doesn't matter if I put 20 squared first or 12 squared, we'll just do it that way. Okay. 20 squared is 400, 12 squared is 244, equals C squared, so I have 644 equals C squared, and then I can take the square root, okay? Notice how fast I'm going through and doing these, since I know that some of that stuff is in my head, like I know what 20 squared is in my head, 12 squared is in my head, I can add those two together, okay? And I'm saving myself a lot of time by not using my calculator, and that's what we want to try to do. So that'll just make things go faster when you guys go to take the ACT someday, and all that good stuff. Try to do as much as you can in your head, okay? The square root of 644 is 25.4, let's say. 25.4, and it doesn't say units, so we'll just leave it as 25.4. That's how long this guy should be, okay? All right, moving on. Now we have proportions, okay? So a lot of these are going to be cross multiply, divide things right here. Number 20, though, they say the ratio of the sides of a triangle are 3, 5, 7. Okay, so here's my triangle. I don't know what he looks like. We'll say 3, 5, 7. Okay, that does not necessarily mean that this is a length of 3, a length of 5, and a length of 7, because really it could be, let's say, 6, 10, and 14, right? Those are also going to have the ratio of 3, 5, 7 because that's just double what 3, 5, 7 is. So in lowest terms, this would be 3, 5, 7 as well. So really, we know that the perimeter is 450. 3 plus 5 plus 7 is not going to add up to 450. But this is 3x, 5x, and 7x, okay? And x is going to be like my scale factor. So in this case, x would be like 2, because this would be 3 times 2, 5 times 2, 7 times 2. Okay, so I need to figure out what x is. And I know that all three of those things are going to add up to be 450. Okay, so 3x plus 5x plus 7x. 3 plus 5 is 8, 8 plus 7 is 15. So I have 15x equals 450, okay? And if I divide by 15, x is going to be equal to 45 divided by 15. If you think of a clock, 45 minutes, that would be 3, but 450 would be 30. So x is going to be 30. So the measure of each side of the triangle is 3 times 30, 5 times 30, and 7 times 30. So my triangle really looks like 3 times 30 is 90, 5 times 30 is 150, and 7 times 30 is 210. That's what he is going to look like. Okay, those three measurements. Then the measure of each side of the triangle, that's what he looks like. Okay, so each one of these triangles is going to be similar. They're all similar triangles because they have the same shape, but they're just different size because all of them are in the relationship of 3, 5, 7. It's just they're scaled up by a larger factor. Okay, solve the proportion. This one you guys should be able to do by yourself. So you're going to cross multiply. I might just have you guys do this one by yourself. And then I'll reveal my answer here in just a second. So, okay, so the answer that I got was 30.1, rounded to the nearest tenth. There he is. Okay. 24, find the following polygons are similar, find the value of x. X is this guy right here. Now they're not facing the same direction, but that's okay. What we can do is I'm going to take this triangle, and I'm going to flip him around to maybe make it easier to see how this works. So if I take him and flip him around, this top side is going to be 12 and this side is going to be 9. Okay, so now I can kind of see how these two are going to relate to each other. Okay, this 10 really is not ever going to be used because I don't have a side here, but I can use the other 4 pieces to make a proportion. Okay, so let's start with x. X on this guy corresponds to the side 9 on this guy, and 8 for this guy corresponds to 12. Okay, so then I cross multiply. 9 times 8 is 72. 12 times x is just 12x. Okay, and if I divide by 12, 72 divided by 12, you might know what that is in your head. 72 divided by 12 is 6. That's what he is. Okay, so find the value of x. Might help to rewrite the triangle so that they're facing the same direction, and then you can clearly see what's going on. Okay. Next one. Find x. It's really super important to note that these 3 lines are parallel to each other because that's the only way that this will work. So what I can do is I can set up a proportion. I can either do like 3 over 4 equals x over x plus 4, or I can do 3 over x equals 4 over x plus 4, any of those. Okay, so let's go left to right. We'll go 3 over 4 is equal to x over x plus 4. Okay, I can do it that way. So left to right, left to right. Okay, and then I'm just going to cross multiply. So here and here. I'm going to start with a 4x. So 4 times x equals, now be careful. Some of you guys know that I'm going to tell you to be careful on this because 3 times x plus 4, I have to distribute the 3. So 3 times x is 3x. 3 times 4 is 12. Okay, don't just make that 3x plus 4 because you have to multiply the 4 by the 3 also. Okay, then we're just going to subtract 3x. So x is going to be equal to 12, and that's it. Okay, now that's only legal. You can only do that if those 3 lines are parallel to each other. Okay, so there's that. All right, determine whether the dilation from A to B. Okay, so we're starting with A and we're going to B. Is an enlargement or a reduction. So if we're starting with the bigger one and going to the smaller one, we are doing a reduction. Okay, and then they want us to find the scale factor of the reduction. Okay, so what I do is I look at one of the sides, and the easiest side to look at is this one because I can't really figure out what this length is unless I do maybe the distance formula or whatever, or this length. I would have to use the distance formula, but this one I can see is 1, 2, 3, 4 units in length. And this guy right here is 3 units in length, okay? So when I'm doing this, my scale factor, okay, I know that my scale factor is either going to be 4 over 3 or 3 over 4, okay? Now, which one of those is going to reflect a reduction, right, like making it smaller? 4 over 3 is a number that's larger than 1, so that's going to be an enlargement. 3/4 is going to be my reduction, okay? Or another way to think about it is end. I think we just had this in like section 10.4, I think, or something. You do the ending over the start. That's how you find your scale factor. So my ending length here was 3, my starting length was 4. So there's my scale factor. Okay, but make sure that's consistent with reduction and enlargement. If it's a number less than 1, it's going to be a reduction. Bigger than 1, it's going to be an enlargement. Okay. All right, last one for similar triangles. This is probably the one that you'll see on standardized testing the most. And draw a picture. A 5-foot vertical pole casts a 3-foot 4-inch shadow. Okay, so I have this going on here. Here's my pole. This is a 5-foot pole and a 3-foot 4-inch shadow. Okay, that's going to be important here. Just a second. We've got to figure out what he is in as a decimal. Okay, and then it says an oak tree casts a 20-foot shadow. Okay, so if the shadow's here, they want us to find the height of the tree. That's what we don't know. Okay, so we can call him x if we want to. Now, the problem with this, we're going to set this up as a proportion. So like 5 over x equals this over 20. Okay, but 3 foot 4 inches is not the same thing as 3.4. That's not 3 foot 4 inches. Okay, this is 3 foot and 4 out of 12 inches. Okay, because 12 inches are based in 12 inches to a foot. So 4 inches would be 4 over 12, okay? And 4 over 12 as a fraction is, 4 over 12, but it's 1/3 if you reduce it, or this would be like 3.33 is what 3 foot 4 inches is, okay? So 4 over 12 is 1/3 or 0.33. So do not write that as 3.4. It's 3.33 technically. Okay. So now we can do our proportions. So you could set this up a different way. I'm going to do 5 over x equals 3.33 over 20. Okay. And 3.33 is a rounded number, so we're going to get something that's even further rounded, but it'll be all right. 5 times 20 is 100. 3.33 times x, and then we have to divide. 3.33 and 3.33. X is going to be 100. 100 divided by 3.33, and it is 30.03. That's what he will look like. So he's about 30 foot tall. I think if we wouldn't have rounded, we would have gotten 30 foot exactly on the dot, but we'll go with that. Okay. All right. Chapter 8. This is all trig stuff. Okay. So some of these are going to go fast, and some of them are going to be like 33, 34 are going to take a little bit of time. Okay. But we'll just stop at 35 here in a minute. So they want us to find what x is. Okay. They don't give us the measure of any of the angles, but they do tell us that this is 8 and this is 17, and this is a right triangle. So we've already done a problem like this. We can use the Pythagorean theorem. Okay. Now 8 and 17 and this x is a perfect right triangle, and I'll show you that here in a second. It's 8 something 17. So if you can kind of remember what that guy is, you wouldn't have to do the Pythagorean theorem. But we'll go ahead and do it because 8, whatever, 17 is kind of a hard one to remember. So 17 has to be my side C. So make sure you identify him to start with. We'll go 8 squared plus x squared equals 17 squared. Okay. Do as much as you can in your head. 64 plus x squared equals, I think that's 289 is what 17 squared is. Let me check. 17 squared, 289. Okay. And then I'm going to subtract 64 from that. Okay, so x squared equals 289 minus 64 is 225. And if I take the square root of 225 comes out nicely. It is 15. This is a perfect triple where it is 8, 15, and 17. Okay, there was other triples that we had, which was like 3, 4, 5, 5, 12, 13 was a special one. 7, 24, 25, 25, 8, 15, 17, and 9, 40, 41. Those are like the main 5 that you're going to see ever. Most of the time it's only going to be these two that you're going to see, the 3, 4, 5, and 5, 12, 13. Those ones at least you should have memorized. But 8, 15, 17 is one that comes out really nicely. So there is that. Okay, they want us to find sine of j, cosine of j, and tangent of j. And we'll do this. And they want us to write them as a fraction. Okay. So j is this angle up top here. That's the important part. That's what we're looking at. Okay. And if you want to write out your SOHCAHTOA, SOHCAHTOA. That's what he is. Okay. SOHCAHTOA. All right. Sine is going to be opposite over hypotenuse. Okay, so if I'm looking at j, the opposite side of j is going to be 24. Okay, so opposite, and the hypotenuse side is going to be 40. Okay, so it would be 24 over 40, or if I divide everything by, let's see, I think I can divide by 8. 24 divided by 8 is 3. 40 divided by 8 is 5. Okay, now, since I reduced that really nicely, what I'm going to do over here is, to make these two go faster, I'm going to go ahead and reduce these guys here. I'm going to divide everything by 8. So 24 divided by 8 is 3, 40 divided by 8 is 5, 32 divided by 8 is 4. This is a 3, 4, 5 triangle, just like I just got done talking about. Okay? So reducing them over here will make it so I don't have to reduce these last two. So cosine is adjacent over hypotenuse. Okay? The adjacent side to angle J is going to be 4. The hypotenuse side is 5, and I don't have to reduce that because it's already reduced. Okay, and the last one is tangent. So opposite over adjacent. Opposite is 3. Adjacent is 4. So 3 over 4. That's what he will look like. Okay. All right. Moving right along. Number 30. Okay. They want us to find the value of x. Okay, and they give us that this guy is 45 degrees. Okay. So we had some some triangles that we learned, like a 30, 60, 90 and a 45, 45, 90 triangle that we learned, earlier on. But if you don't remember those ratios, like 1, 1 square root of 2 and 1, 2 square root of 3, if you don't remember that, let's just go ahead and do SOHCAHTOA with these guys. So SOH, CAH, and TOA. We can go ahead and do that this way, okay? 45 degrees is the angle that we're looking at, and 14 is adjacent, and X is going to be the hypotenuse, okay? We're not using the opposite. We don't have any information for. So which trig function are you going to use for A and H? We're going to use cosine, okay? So we write out cosine of 45 is equal to adjacent, which is 14 over X, okay? And then since the X is in the bottom and we're trying to solve for him, okay, we're going to flip those two guys around, and X will be 14 divided by cosine of 45, okay? Make sure your calculator is in degrees. 14 divided by cosine of 45, close parentheses, okay, and we get 19.8-ish. So X equals 19.8, and that's how we can solve for him, okay? All right, let's move on to 31. This one we have to do the SOHCAHTOA way. So SOHCAHTOA. 64 is the angle that I'm looking at, okay? X is going to be my opposite side. 11 is going to be my adjacent side. The hypotenuse side we don't have information for, so we're not going to use H. So we're just going to use O into A, and that's going to be tangent. Okay, so tangent of 64 equals opposite over adjacent, X over 11. Now, since the X is in the top here, I can just multiply the 11 to the other side, which makes things really kind of nice. 11 tangent of 64. Okay, X is going to be equal to 22.6-ish, and that's what that opposite side will be, okay? All right, a couple more here. Find the measure of angle T. Okay, now, angle T, we're solving for an angle here, but we still have 7 and we still have 18, okay? So we're still going to kind of do the SOHCAHTOA method, SOH, CAH, I don't know why I keep rewriting this, but that's okay. SOHCAHTOA. All right, 7 is opposite of T, 18 is the hypotenuse side because it's opposite the right angle, okay? The adjacent side here is the one that we don't have any information for, so we're going to use opposite hypotenuse, which is sine, okay? Now, this one is kind of weird because normally we take sine of the angle, or cosine of the angle, or tangent of the angle, but here we don't know the angle, so we're going to call him T. But we do know both of these pieces over here. We know that sine of T is 7 over 18, right? Opposite over hypotenuse, okay? Then to get this T out of there, or to get rid of the sine, I have to do that inverse sine, okay? So T is inverse sine of 7 over 18. Second sine, 7 over 18. And he will be 22.9-ish, okay? We're going to round to the first decimal place, okay? And there's what he is. All right, 33, 34 are going to take a little bit more time, I think, maybe. Hopefully we can get through those kind of fast, though. 33, they say solve the triangle. So they want capital A, capital B, capital C. They want lowercase a, lowercase b, lowercase c, okay? So some of these I already know. Like I know the sides, 22, 20, and 16, okay? But which one is which? Like which one is lowercase a? Okay, well, lowercase a is going to be across from capital A, so 22 is going to be lowercase a. So we're going to put him here, okay? Which one is lowercase b? That's going to be my 20, and lowercase c is going to be 16, because those are the ones that are opposite, okay? Now, if I'm trying to find an angle, I have 3 sides, and the formula that uses 3 sides and 1 angle is going to be the law of cosines, okay? Law of cosines was a squared equals b squared plus c squared minus 2bc cosine of capital A, okay? And it doesn't really matter what you've named these, but I need to make sure that lowercase a and capital A are like on opposite ends of each other, okay? When we went through this, I remember explaining to you that those have to be opposite from each other. So let's go ahead and let's just solve for capital A here. Capital A will leave, so we'll have cosine of capital A. A squared will be 22 squared. B squared will be 20 squared. 16 squared minus 2 times 20 times 16, and then cosine of a, okay? Now, don't try to do too many pieces at once. We can figure out what 22 squared is. That one I don't know. 22 squared is 484. Okay, I do know that 20 squared is 400. 16 squared is 256. 2 times 20 is 40. And 40 times 16, I know that 4 times 16 is 64. So this would be 640 cosine of A. That's what he would look like. Okay, now let's go ahead and put these two pieces together. 400 and 256 is 656. Okay, now I don't want to subtract the 640 from him because 640 is attached to the cosine, so I cannot do that. Okay, then I'm going to go ahead and subtract the 656 to the other side. Okay, so he has gone 484 minus 656. Okay, is negative 172 equals negative 640 cosine of A. Okay, now we're almost done unwinding the equation. I need to get rid of the 640. So I'm going to divide by negative 640. And what that's going to do is it's going to turn this left side to be positive. So negative 172 divided by negative 640 is going to be 0.26875. Blech. That's what cosine of A is. Okay, now to get just A, I have to do inverse cosine. Okay, and always try to use that answer button in your calculator because then you don't have to retype. So I would do second cosine, second answer is how my calculator does it. Okay, your answer button is all the way down here with like the negative if you have the same calculator as me. So that's what it will look like. And it will tell me that A is 74.4 degrees. Okay. All right, so 74.4 degrees. Okay, now from here, I need to figure out what B is and what C is. Okay, so what this is going to do is this is going to go just a little bit faster, I think. When I'm trying to find B, since I already know what A is, I can now, instead of using the law of cosines, I can use the law of sines instead. So that was like A over sine A equals B over sine B. They might have put the signs on the top. I'm not quite sure how your book wrote that. But anyway, so we'll go ahead and do A over sine A is 22 over sine of 74.4. That's what A over sine A is. And B is 20 over sine of capital B. Okay, so A over sine A, B over sine B. And then what we do is we just cross multiply. Okay, so I'm going to multiply those together, and I'm going to multiply those together. Okay, so on the one side, I'll have 22 times sine of B, and on the other side, I'm going to go ahead and multiply those together. 20 times sine of 74.4. Okay, and that will be 19.26, or whatever that is. Okay, now to get B by itself, divide by the 22. That will be sine of B, divide by 22, and we have 0.876-ish. Okay, all right, whew, that's a lot of work. Now let's do inverse sine. Inverse sine, B is going to be second sine of the answer. And B is going to be 61.1 degrees. Okay, 61.1 degrees. Oh, that was a lot of stuff going on. All right, I'm still not done. I have one more thing to do, except this one's the easiest one of all. Now that I know A and B, I can just add those two together and subtract from 180 to get C. So I don't have to do any of the law of sines or law of cosines again. 74.4 plus 61.1, and I'm going to take 180 minus that answer, and I get 44.5 degrees. So that one was a little bit nicer. Okay, all right, I think let's go ahead and skip number 34 because it's going to be a law of sines and law of cosines again, but since we did both of them here, we're just going to go ahead and skip that. And then we'll do 35 and we'll stop. So determine whether the following is a right, obtuse, or acute triangle. Okay, so the rule with this is if it's a right triangle, you can use the Pythagorean theorem, which is that a squared plus b squared equals c squared. This tells me that it's a right triangle. Okay, now if the two sides that I'm adding together are bigger than the third side, meaning that this guy is a little side. So the largest side that I'm supposed to have is supposed to be C, but he is still a little side. That means he's going to be an acute triangle, okay? Because in an acute triangle, this is what an acute triangle looks like, okay? I would say that my largest side is probably the bottom, but he's still a small side, technically, because he's less than the other two added together. So that's going to tell me that he's an acute triangle. Now, if I have the other way around, where the two sides added together are smaller than the c squared, and that means I have one really, really, really large side, like this. This would be my side C, so that is going to be larger than these two added together. That means this, my big side is a really big side, and this tells me he is an obtuse, okay, triangle. So when I do this, make sure that you're not just putting them in order like A, B, C. C has to be your largest side, okay? So C in this case is going to be 31, and then it doesn't really matter what I designate the other two to be. This sure will just have A be 18 and B be 27. So let's go ahead and write out 18 squared plus 27 squared. We'll see what he is in comparison to 31 squared. Okay, and none of those I really know. I don't really know what any of those are. 18 squared plus 27 squared. This whole left side is 1053, and 31 squared is 961. Okay, so going by just those two numbers, I can see that this guy is bigger than this one, which means that my C side is little because it's smaller than the A plus B. So this is going to be an acute triangle. Okay, those sides put together are going to be acute. Oh my gosh, that was a lot. Okay, so we'll finish up tomorrow, and then that will be your last day. Yay!